sick.
You okay?
What can we do to help?
I'm okay. Nothing. I gotta come, Gary.
Array Biopharma, Gary speaking.
Gary, we have a problem. Purple Sneezitis is spreading around the school.
I understand. We know what to do. My name is Gary Hingorani, and I'm a drug metabolism scientist at Array Biopharma. So I was born in India. We came to the US when I was about a year old, and we moved from New York, Illinois, Iowa, Wisconsin, and then eventually to Michigan. And I basically grew up in Michigan from the age of 13 on. Drug metabolism science is where you look at how a drug gets absorbed, distributed, metabolized, and excreted in the body. A drug is taken by mouth, it enters the GI tract, it gets absorbed and enters the bloodstream. From there, it'll get distributed to the different organs in the body, and then it will get metabolized in the liver and then excreted. So, looking at this slide, you can see the number of reasons for drug failures, right? And what we focus on is the poor PK and ADME portion, right? For which 40% of drugs have been shown not to work. And the types of tests we run, we basically want to make sure that a drug is going to be absorbed well, and that it's not going to be rapidly metabolized, and that it won't lead to drug-drug interactions. So we want to make sure that it's going to be safe and that it's going to work at the site of action. A drug-drug interaction is where you may be taking one drug and then you take another drug which influences how the first drug gets metabolized. So you can imagine a case where you have drug A and it's being metabolized by specific enzymes in the liver. You take drug B, it inhibits those enzymes, and now the levels of drug A shoot up way through the roof and it can lead to toxicity. So in doing drug development, we start with a target that we're going after, and this may be an enzyme or a receptor that's involved in a cancer. And then we start by generating a lead, and then we do lead optimization where we improve the efficacy and profiling for druggability, which is improving the absorption, distribution, metabolism, and eventually excretion of the drug. And then after we come up with a candidate, it goes into clinical development where we actually prove that the drug is going to be safe and efficacious in man.
I'm Jennifer Otten, and I work in drug metabolism, checking for drug-drug interaction. When you give a drug to a person, if they're already on another drug and you inhibit that, you're going to change the activity of that drug that they may have already been on.
My name's Karen Brown. So I take a compound and put it into liver cells, which are called hepatocytes, and then look at how fast the drug is cleared through the liver over certain time points.
My name is Jamie Rogan, and I've been working at Array for about 2 years now. And the specific assay that I run looks at a key transport protein and whether or not our compounds are getting into the cell and whether or not this protein is actually kicking it back out of the cell. So it's an important fact that tells us a lot about permeability and some of the efflux, is what they call it, characteristics of our compounds.
My name is Ben Colson. Well, I'm a research associate in the drug metabolism department, and my focus is in physiochemical properties. I analyze our discovery compounds mostly to determine the solubility. The solubility is important for how well a drug taken orally is absorbed into the body.
Okay, you've had a chance to see how we improve the drug optimization process. This system is one in which we use to assess cardiotoxicity. We use these 96-well plates that have microelectrodes on the bottom, and we're actually able to plate cardiac cells in these. So these are actually stem cell-derived cardiomyocytes, and they actually display a beating profile through this impedance-based detection system. So in short, we basically get a little electrocardiogram for each well. And inside each well, we can test a different drug at a different concentration. and assess whether it's going to be safe or whether it may lead to arrhythmia or other cardiotoxicities. And et voila, it's a cure!